Okay, so far we've looked at the quadratic equation, the quadratic sequence equation or general term. This is actually a general term. This is not really called an equation here. It's called a general term. This is a general term. So we've looked at that and we evaluated, we looked at what it would be at T1, T2, T3, T4, and we looked at what would be the first difference, what would be the constant difference. And then we concluded that our second difference would be constant, our first difference would be arithmetic, and the actual function itself would be a quadratic. Now, I want to give an example. I want to give an example. Yes, I want to give an example on a quadratic function. So let's get an example here. Which color do I want for an example? Let's have an example. I'm sorry. An example, this would be an example. Let's say the first term is -6. Okay, I like writing the first term here. -6. The second term, 4 minus 2, that's 4 minus 2, what is that? Okay, I'm sorry guys, I am trying to make this up. So just give me one moment to get that right. So minus that, -6. Okay, so this is 1. Oh, so no, this is 2. This is 2. So our next term is -4. And our third term is 3. Our third term is 3, and that is 0. And our fourth term is 6. Okay, cool. That's our general term. Now I want us in this that's our sequence. I want in this sequence to find the general term. So we go and find our first difference. Our difference is going to be -4 minus -6. So it's -4 minus -6. That's a 2. And then the second one is 0 minus -4. So that's a 4. Then it's 6 minus 0. So that's a 6. Can you see, guys, that this is actually a linear pattern? This is our first difference, and it's a linear pattern. And then our difference from here, it's going to be a 2, and this is going to be a 2. Are we happy? Are we happy?
Yes, sir.
Now, guys,
Yes,
I want to show you. This is in a general term, right? But maybe let me use highlighters. But this term here, over here, in this position, is equivalent to this term here. This term, I'll actually do the whole entire thing, is equivalent to this term. So this term over here. And this term over here is equivalent to this term that is here. And this term over here is equivalent to this term over here. And this term over here, it's equivalent to this term over here. I'll show you an exercise. You know, I grew up where my father had his own plate at home. You know, if we're eating a certain meal, you know, you eat a certain meal with certain cutleries and dishes and things like that. Yes. So he had his own, right? It's the same with this. Each and every pattern, whether you are given in numerical order, it has its true value. You know, minus 6 is made by A plus B plus C. You know, this 2 is made by 3A plus B. You know, this 4A, this 4 over here is made by 5A plus B. Now you'll see that. So let's try to find the general term. The general term, our approach is going to be as follows. We're going to say that 2A is equal to, do you see this 2A, this here, this 2A over here? That 2A will be equal to 2. Are we happy?
Yes, sir.
So we're going to find our A. Our A is going to be 1. Are we happy?
Yes, sir.
Remember, let me just go back before I carry on. Remember, finding the general term just means that you're finding A, you're finding B, and you're finding C. So that's why that 2A would be that. And then, so if you go back here and you look at this term, 3A plus B, that 3A plus B will also be equal to 2, this particular 2 over here. Are we happy? The 3A plus B will also be equal to 2. But right now, we already know what A is 1. So we're just solving for B. So our B is -1. Now, we know that this one over here, A plus B plus C, is equal to this guy over here, -6. So we can go and say A plus B plus C is equal to -6. And when we look at A, we know what A is. By now, we also know what B is. So we're looking for C. The 1 and the -1 are going to cancel. So we're going to find that C is -1. So our Tn effectively would be, our A is 1, so it would just be n squared. Our B is -1, so it would be -n. Our C is -6, so it would be just 6. Very similar to what we were doing when we were finding cubic functions. But there's a different method of doing it. Do you see, guys? Are we following?
Yes, sir.
Sir.
That's how you find Tn. But I want to show you this. I want to show you that in these matrices, or maybe in these, what are these things called now? In these numbers, I want to show you, let's highlight that maybe with this one because they are the same. I want to show you that it actually doesn't matter what you choose. So if you say, you want to say 2A, which is this 2A over here, which is this 2A over here. If you want to say that 2A is equal to this green 2, then you will do that and you will still get the same A value, which is 1. But if you want to say 5A plus B, do you see 5A plus B? If you want to say 5A plus B is equal to that 4 highlighted with the green color, just as 5A plus B, you know, if you want to say that, that is equal to 4, and you say, I know my A is 1 plus B is equal to 4, your B will also still be -1, you know. And if you want to say 4A plus 2B plus C, you know, 4A plus 2B plus C, 4A plus 2B plus C. If you want to say that is equal to -4, if you want to say that is equal to -4, you already know what's your A, you already know what's your B, you want your C now. So that would be 4 minus 2 plus C is equal to -4. And that would be 2 plus C is equal to -4. Your C would be -6. So once again, you will still get n squared minus n minus 6. So you can actually mismatch. I actually want to show you that you can mismatch as long as you are consistent with what you are matching. So you can choose to use this blue one over here and that, you know, and maybe this one over here. As long as you are very true about your position, those blue ones over here will correspond to these and this and that, right? So let's go ahead. Now, I hope this exercise might seem trivial for what I'm going to say later on, but it's not. So again, your 2a, your 2a is still equal to 2, so your a is 1. And then if you go use that 7a plus b equal to 6, your 7a plus b is equal to 6. And therefore your a we know is 1, your b is equal to that, that's equal to 6. So once again, your b is equal to -1 because it's 6 minus 7, that's -1. And we're going to do lastly, 16a plus 4a plus 6 plus c, that would be equal to 6. So this is 16a, we'll do it here. 16a plus 4b plus c is equal to 6. Now we already know what a is. Our a is 1. Our b we know is -1. Our c is what we are looking for, and all that together is equal to 6. Now this is going to be 16 minus 4. That would be 16 minus 4. That would be 12 plus 6 plus c is equal to 6. If we take the 12 to the other side, we'll have 6 minus 12, which 6c would then be equal to -6. So once again, as long as we are very consistent with what we match with what, we still get the same thing. Now, guys, are we happy with that?
Yes, sir.
Nevertheless,
Yes, sir.
even now that we know that it doesn't matter what we match with, if we are being consistent with what we match, I highly recommend that we only use the first ones. Use these ones only. Ooh, I made that very dark. Oh, yeah, because that was a blue and green. That combination would give me a particular color. Let me actually undo all of them. So I recommend that you only match the first row so that you never get confused and mix up things and you think you're at the 3rd term, but you're on the 4th term. So just stick with these ones. Stick with this row. Or column, I don't know. Are you happy? So just do 2 with 2a, 2 with 3a plus b, and a plus b, and that's what you would see certain textbooks doing. However, you will see why maybe very later on when we're dealing with past papers, why that analogy would be helpful. And yeah, that's our, let me just take a second. That's our sequence and series. That's our quadratic equations or quadratic patterns. I'm not sure if I want to go further than that. Technically, I should, but I'm not sure if I want to. But I would rather want people to engage with me and ask questions on this one. I would rather require people to engage with me and ask questions. Or I can see if I can check for nice questions for you guys to answer. I don't like you guys when you have a lot of work to do outside class. That's good, but I've come to notice that might not benefit you as I intended to do, benefit you. Yeah, I don't have amazing problems with me right now. So I just have like normal problems. But maybe let me stress something else. It's just that now you found your TN, is equal to n squared minus n minus 6. So you can still be asked the problems that we interacted with yesterday. I just want you to note that. So these questions that we're doing yesterday, they are not necessarily limited to the arithmetic pattern. So someone can ask you, prove that this sequence is quadratic. So to do that, you have to find that the second difference is constant. You know, someone could be like, so they can give you the general term, and then they can say, find the value of the first two terms when given the following general term. You still should be able to do it. Someone can be like, determine the general term of the following sequence, which is partially what we just did. Even also number 2, it's what we did concerning when we're trying to derive the general term, or just to show you that pattern, or la map. Yes, so you should still expect these questions. Determine the 11th and the 100th term. You should still be able to do these. Determine how many terms are there. You should be able to, you should still expect all these questions in a quadratic sense. You should still be able to anticipate those questions that are coming up. Okay. Now I'm gonna stop the record. I don't think, I'm a low-key one to ask complicated questions, but somehow, it's probably because I don't have them in front of me. I don't have nice questions, and I can't just think on top of my mind with this one. It will take me some time. Or maybe let me do a nice question. Yeah, that also will take me some time. Yeah, and I don't want to confuse you when things are not working out as I wanted them to do. So let me stop this particular record.